Chapter 10, Section 6 is volume of prisms and cylinders. And the volume is the number of cubes that will fill a shape. Number of cubes that will fill a shape. And we start out with a prism. This is a right triangular prism. This is an oblique triangular prism. And to find the volume there, you do the area of the base times the height. If you have a rectangular prism, it will be length times width times height. And the volume of a cube is just that side cubed. So finding the volume of this first one, length times width times height, 13 times 3 times 5 is 195 centimeters cubed. To find letter B, first we need to find the area of the base, which is 1/2 the apothem times the perimeter. 1, 2, 3, 4, 5, 6. The perimeter is 6 times 9, which is 54. And to draw our triangle, 360 divided by 6 is 60. That makes this 30. And half of 9 is 4.5. So we say the tangent of 30 is 4.5 over x. Solving that, you do 4.5 divided by the tangent of 30, and that tells us our apothem is roughly 7.8. So we put that in here, and then we have 1/2 times 7.8 times 54. The area of that base is 210.6, and we multiply that by the height, which is 12, and we get 27.2 feet cubed. Example C, find the volume of a triangular prism, height of 9, base is a right triangle with legs 5 and 7. Well, the area of that right triangle then is 1/2 base times height, which will be 17.5, and then we multiply that by the height, which is 9, and you end up with 157.5 cubic yards. And a cube with an edge length 15. The volume of a cube is side to the third. So 15 to the third power, that is 3,375 inches cubed. Now the next one, we have a swimming pool that is a rectangular prism, and we want to know how much water this will hold when it's completely full. So let's first find the volume, which is 25 times 15 times 9, and that is 3,375 cubic feet. 1 gallon is 0.134 cubic feet, and then water is 8.33 pounds per gallon. Notice how feet and feet cancel, gallons and gallons cancel, and we have 3,375 times 8.33 divided by 0.134, and that will weigh 209,804 pounds. Next part, volume of a cylinder with the base area of B, radius in R, and H is height, is volume is base times height, or pi r squared times height. This is a right prism or right cylinder. This is an oblique cylinder. And Cavalieri's principle says that if two three-dimensional figures have the same height and the same cross section, then they have the same volume. So for volume, we are always going to do pi r squared times height. The volume of this first one then will be pi. The radius is 9. So pi times 9 squared times 14. That volume is 3,560.76 inches cubed. Letter B, cylinder with a base area of 121 pi. So they already give us our base, but the height is equal to twice the radius. So if the area is pi r squared, which is 121 pi, we square root both sides. Our radius is 11. So it says height is equal to twice that. So our height will be 22. So 121 times 3.14 times 22. And the volume is 8,358.68 centimeters cubed. And example C, find the volume of a cylinder. Diameter is 16 and the height is 17. Well, if the diameter is 16, the radius is 8. That's the radius right there, not 18. So pi r squared times height, which would be pi times 8 squared times 17. 8 squared times 17 is 1,088 pi. And if you multiply that out, that is 3,416.32 inches cubed. Exploring effects of changing dimensions. If you change your volume, volume is to the third power. So if you change your radius and height, volume is to the third power. So you will raise that number to the third power, and that would be 8 over 27. If the length, width, and height are doubled, then the volume would be by 2 to the third, which is 8. And finding the volume of composite shapes, this prism right here, we can do length times width times height. And the volume of this bottom part is 160. To find the area of this top, your triangles are actually the bases. And to find the area of that base, it's an equilateral triangle. So I'm going to do 1/2 A, B, sine of C. That will give me the area of that triangle. And your height in this case is right here, which is 4. So the area of the triangle times the height. And if we add that, punch that into our calculator, oops, sine of 60 times 4, we end up with a volume of 270, let's just say right about 271 centimeters cubed. We added the volume of this and then the volume of the top triangle. And for this next one, we're going to find the volume of the cylinder, which is pi r squared times height. And then we're going to take out that square prism in the middle. Well, this is a square, and I'm going to use that as a rhombus. And if you remember, the area of a rhombus is 1/2 diagonal 1, which would be 6, times diagonal 2, which would be 6. So that 1/2 diagonal 1 times diagonal 2 would give me the area of that square, and then we multiply that by the height, which is 5. And entering that in our calculator, 3.14 times 3 squared times 5, and we are going to subtract 1/2 diagonal 1 times diagonal 2 times the height, and I got the volume as 51.3 centimeters squared.